Yes, let me start.
Yes, sir.
Yes,
Yes, sir. Sir,
Prajapati.
am I audible?
Yes, you are audible. No problem. Yes, your project name is hydrothermal synthesis of magnetic cobalt ferrate. C catalyst for environment remediation.
Yes, sir.
Yes, what the role of your MSc
Yes, sir.
project? इसका role क्या है? What the role?
Sir, the role of catalyst is in our environment, like in industrial wastewater discharge, pharmaceutical company, wastewater pharmaceutical company. There are various dye used, and also in some synthetic laboratory various dye used in the lab. Therefore, in that case, 4 nitrophenol is generated, and that is carcinogenic in nature. Therefore, if we can change this substance to in a definite substance that is not hazardous for our health, and also beneficial for the environment. To eliminate this substance and converting that substance to any environment suitable substance, we use the catalyst to reduce.
Yes, what is hydrothermal process?
Yes, sir. Sir, in hydrothermal process, basically we take the basically we heated the primary element or material into to 120 degrees centigrade, and 120 degrees centigrade in high heat and in high heat means high temperature, and in a definite time, like 12 hour or 15 hours. So in hydrothermal synthesis, basically we take a autoclave. In autoclave, at first we take various synthetic material that is used to synthesis the catalyst, and then we close the autoclave in such a manner that there is no air can enter into the autoclave. And then we take the autoclave in a system where we can heated the moiety that present in the autoclave to 150 degrees centigrade or higher temperature, like one in our definite room temperature. And also we can take the time at 6 hour. We can fix the time 6 hour or 12 hour or 18 hour, like that. So this is the hydrothermal synthesis, where we use only water. Only water means Di, that is pure water. In that case, any other solvent we cannot use, like ethanol, methanol, or any other solvent like 2-propanol. So this solvent we cannot use. So it is hydrothermal process.
Yes, what is cobalt ferrate? What the role of cobalt ferrate in your project?
Yes, sir. Sir, basically, cobalt ferrite is a transition metal catalyst that we used because at first various process the researcher take to reduce the substance, that is hydrogenation and electrocatalysis, biodegradation. But all the process generate toxic material. So in this case we take as a transition metal catalyst, because in the case of transition metal catalyst they are thermally stable, and also in therefore it is a inverse spinel, and also it has some vacant site where the more amount of hydrogen can it absorb in its vacant site. And also we take a bimetallic, and due to presence of bimetal like cobalt and ferrite is present, it has gained higher thermal stability, and also it cannot also its efficiency is increases. And also we know that transition metals have high charts like oxidation state +2 +3, therefore it can easily reduce any other substance. It is we take it is a magnetic, and when it is magnetic, cobalt ferrite, due to its magnetic nature, we can separate it easily after generating the catalyst. We can separate easily from its waste due to by magnetic separation. That's why we take cobalt ferrite catalyst.
Yes. Your preparation is inverse spinal, I think. Normal is spinal. What the role of in your project?
Mm. Yes, sir. It is cobalt ferrite. Moiety, it is inverse spinal, and and we know that in the case of inverse spinal, it has high octahedral, like in the case of CO is +2 and Fe is +3, and that's why cobalt ferrite and Fe+3 is CO. mm, mm, COFE, it is the cobalt ferrite synthesis. In this case, cobalt is present +2 and Fe is present +3. And 2 Fe is present, and we know that Fe+3 is a D5. D5 is, and D5 means it has CMSC is 0, because in this case when the orbital is splitting apart, when the orbital is splitting apart, we know that -0.4 into 3 d and plus it is stabilized by -0.4, and 2 electron are destabilized by -1.2 +1.2 and 0, and therefore it cannot stable in octahedral environment. Therefore, it cannot give stability in octahedral environment, and it transferred to tetrahedral environment, and therefore, and CO+3, we see that CO+2, it is D7. So when it is D7, we see that from the d orbital splitting, one, two, and due to Hello, sir. Am I audible?
Yes, yes, carry on. Audible. Yes, carry on, carry on.
And therefore it is minus 2.0 plus 1.2, and it is minus 0.8. Therefore it has something CABC, something of CABC, and therefore for that reason CO plus 2 present in octahedral environment and 1 Fe2 Fe plus 3 in present tetrahedral environment, and therefore it show inverse spinel.
Yes. What the beneficial of your MSc project in our society? Beneficial point.
Yes, sir. That's why COAP2O4 is inverse spinal.
Beneficial point of your MSc project in our society. Explain.
Beneficial point, that is mm, mm, it is a hydrothermal synthesis of magnetic cobalt ferrite. So when we know that water contamination has become a significant concern in our recent years, and due to its negative impact it has on our human health, especially with the development and growth of the population. So for nitrophenol is a type of yellow crystal, that solid that emits a strong odor, that has a strong odor, and is commonly utilized in the production of dyes, pharmaceutical, pesticide. So, the presence of 4-nitrophenol in water, including surface and groundwater and the ocean, can occur through various sources, such as industrial wastewater discharge, agriculture runoff, and improper disposal of chemical synthesis. So, which poses a significant threat to the environment and human health. So, exposure of 4-nitrophenol can result in skin irritation, respiratory problem, and harm to liver and kidney. Furthermore, long-term exposure to this substance has linked to higher risks of cancer, especially in the case of gallbladder, liver. It is unfortunate that 4-nitrophenol is commonly found environmental pollutant in industrial wastewater, and which can contaminate it by nearby water resources. So that's why we eliminate this 4-nitrophenol to 4-aminophenol, 4-aminophenol, and 4-aminophenol through the reduction process, such as by the catalytic reduction process we convert 4-aminophenol to 4-nitrophenol. And that is not carcinogenic, that is not human health hazardous, so it is beneficial for the environment.
Yes, any drawback limitation of your MSc project?
Yes, sir. When we take the four nitrophenol reduction in a catalytic process, we see that if we take excess if we take some excess amount of some excess amount of catalyst, then it cannot getting reduced. Therefore we always take optimum amount of catalyst in optimum amount of sodium borohydrate. So we have monitor constantly that optimum amount of catalyst we can take or not. If we take some more amount of catalyst, then it cannot get reduced. Another product, it cannot get reduced, and it can give another product, and that we not need. Therefore we constantly have to monitor the optimum process of the catalyst measurement.
Yes, any other drawback from your side?
Mm, yes, sir. Like in the time of reduction process of 4 nitrophenol to 4 aminophenol, we use various other solvent like by for the purpose, like methanol, propanol, methanol, propanol, two methanol and three propanol, like various process we used, various solvent we take, but we see that it cannot differentiate mass amount in other solvent. Mainly it is getting reduced only in water. In other solvent, it not show that so much of difference for its reduction purpose in any other solvent. So it is a drawback.
Yes, any innovative point from your MSc project? Then will be benefit of our society. Innovative point, innovative.
Sir, innovative point means.
New innovative point, creative point.
Yes, sir. Sir, in Yes, sir. Sir, there are various technique available for eliminating such as biodegradation, adsorption, photodegradation, phenton degradation, electrocatalysis, hydrogenation, and so on. So, however, most of the methods are incapable of efficiently removing 4-nitrophenol, and instead they merely collect toxic substance. And catalytic hydrogenation is highly efficient and environmentally friendly technique that can convert 4-nitrophenol to 4-aminophenol. The reduction of 4-nitrophenol to 4-aminophenol without a catalyst is slow. So finding an appropriate catalyst is necessary to speed up the reaction, and as a result, we have found on discovering efficient catalyst in recent time to achieve highly efficient 4-nitrophenol reduction.
Yes, what the role of 4-nitrophenol reductions in your project? X-ray diffraction, XRD, frontier NMR, FECM, EDEX, dynamic light scattering DL.
Yes, sir. Sir, actually, yes, sir. Sir, actually, these are used to monitor. Actually, these are used to monitor the catalytic performance, like how efficient the catalyst is. So to see the and to monitoring the catalytic performance, we used this type of process, that is at first we to see the morphology of the like to see the crystalline size of the catalyst, we use XRD. Like in XRD, at first we take the sample, and then we run the instrument in a 2 theta angle of 40 degree, and give and the amount of current that is already given in the instrument, that is 40 milliampere, 40 milliampere. So when we measure the sample, uh, when we measure the sample, then we see that in XRD, to measure the crystalline size of the sample, and we use a equation in the software, that is called Scherer equation, and Scherer equation is given by k lambda by beta cos theta, and in this case k is the Scherer constant, and beta cos theta, and theta is the angle, and lambda is the that is the lambda is the that wavelength we give in that time. So from that value, we can determine its radius and its crystalline size from XRD. And also in XRD we get some peak that do not match, that give some peak, and that match with the XRD JCPDS number, and from the when we analyze the peak, we see that there are no single peak come for the carbon that we used in as a alternative, that we used DTPA used in our synthesis time of material. DTPA we used as a carbon source, but there is no significant signal come for carbon in the XRD pattern. So we can see that carbon is amorphous, carbon is not present. And in FTIR, through FTIR spectra, that is always used for discussing the sample discussing the sample surface, like to monitoring the sample surface, we use FTIR. In FTIR always we have to use solid sample, and the spectrometer range that is used, that is 400 centimeter inverse to 4000 centimeter inverse. And if we know that when we produce the material, that is we use hydrothermal like water. So in FTI spectra we get the water band, that is come in 3600 centimeter inverse when we analyze the spectra. And also we see some Fe single bond O bond and cobalt single bond O bond in FTIR spectra. When we analyze the spectra, that means in this case, in the surface of material are also present. So FTIR spectra confirms that. And in zeta potential, through zeta potential, we see. In zeta potential we see the hydrodynamic size of the material and their movement, and in that case also we used a equation, Shomrutsky equation. From that we can determine the hydrodynamic size of the, like when they are present in the solution, how much they like when they are present in water, how they collide. So from there we can determine the diameter of the two material. One is 198 point something, and one is 336.0. So from the zeta potential we determine the hydrodynamic size. And also, and from DRS means diffuse refractance spectroscopy. So diffuse refractance spectroscopy, from that we can determine the band gap means like one is positive charge, another is negative charge, like 15.8, one is and another is minus 19.2. So from that we can determine that they can use as a UV visible catalyst or not. And from that we can know that if when we reduce the 4 nitrophenol to 4 amylophenol, see a graph on a UV visible spectrometer. So their band gap lies in the UV visible spectrometer range. That's why we use DRS spectra. And also we use as a characterization, we use field emission scanning electron microscope and transmission electron microscope. Through scanning microscope we see structure of the material. So both of them are something equal size. Both of them means in one case we use only CFO, carbon ferrite material, cobalt ferrite material, and another case we has a carbon source, that DTA. So and when we for welding we use DTPA. So when we use both of them, so one has carbon moiety as a DTPA source.
Yes, I am audible.
Is audible.
Yes, carry on.
So there is a some agglomeration present in their spherical size. So by using EPA, we notice from the field emission electron microscope. So field emission scanning electron microscope is a electron source of beam is used, like electron source of beam is used to see the surface of the material. So both so after one surface is smoother than the other due to pressure. And from the EDX, that is EDX electron dispersion, from we can determine the like if any other foreign material is present. Or so from EDX spectra we can know the ratio. From the EDX spectra we can know the ratio of ferrous and Fe and cobalt is 1:2. Ferrous, cobalt and ferrous is 1:2, and that give the formula similar to COAP2O4. So from the spectra we can know that any other foreign material is present or not. So in that all that process we know, we come to know about the material that we prepared. So it is
Yes.
Yes, sir.
Next is DRS, diffuse reflections spectroscopy. What the use of DRS?
Sir, from the diffuse reflectance spectroscopy, we can determine the band gap of the material, like and from the diffuse reflectance spectroscopy, when we observe the result by using a equation, and that equation is called the in DRS spectra, the equation is used, that is the name is equation name I forgot. uh, uh, in UV visible range 400 to 800 nanometer, we use as a we take the source of BaSO4, and we use the UV visible 550 spectrometer, and from the DRS spectra we can determine the band gap, and from the band gap we see that one moiety has the positive band gap, and one has negative band gap, and from that we can determine that they are suitable for the UV visible spectroscopy or not.
Yes. Next one is zeta potential. What is zeta potential? And what the use of zeta potential in your MSc project?
Band gap,
Yes, zeta
sir,
potential.
the band gap of CFO and CFOC was lying in the visible region. That's why we can know that it is UV visible spectroscopy. So sorry, sir. Can you repeat the question?
Zeta potential. What the role of zeta potential in dynamic light scattering DALS? Yes, what the
Yes,
role
sir.
of zeta potential
Theta
in
potential and
DALS?
dynamic light scattering.
Yes.
Sir, I have to see the some. Hello, sir.
Yes. Carry on. Zeta potential. Last question mark.
Sir, 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 I have the instrumental part like theta potential instrumental part, APACM instrumental part. I have to read about it. So, sir, can I give tomorrow mock interview?
Tomorrow his topic is coordination.
Tomorrow topic is this my project instrumentation part. Like, sir,
Yeah, today, yes,
instrumentation
Abhi,
part
now,
means
yes, now, yes,
explain.
now, okay, now 5 minutes left. Now discuss on your MSc project. Yes, now, other topic. Yes, XRD,
Yes, sir. Yes, sir.
X-ray
Sir,
diffraction. What the
like, sir,
main role of
actually,
XRD?
uh, sir, yes, sir. I have to read about their instrumentation part. I am not read about. I read before, but I forgot something. Like, so we have to. I have to prepare X-ray diffraction instrumentation part, FT instrumentation part, FESEM, and instrumentation dynamic light
Okay, okay,
scattering
okay.
and zeta potential
Okay, okay, no
and,
problem.
and
Okay, okay.
diffuse reflectance spectroscopy.
Yeah, next day we will discuss in the left
Yes,
part of
sir.
your MSc project. Okay. Okay, thank you.
Yes, sir. Yes, sir. Basically, sir, the material characterization part.
Yes, material characterization part. Yes. What the basic role of material
Yes,
characterization?
and sir, yes, sir. And sir, we have to prepare for their result, like kinetics of 4 nitrophenol. Okay, sir. Hello, sir.
Yes.
Sir, then next day we have to discuss about that.
Yes, good. Yes, good. Thank you.
Thank you, sir.